right, ready? Number 11, I can already tell it's going to be a quadratic equation problem because of the things they gave us. So if you look at this one, you'll notice that if I want to use my formula to find the missing sides and angles, which is the requirement for number 11, I want to usually have the one I'm looking for and the angle I'm going to use be opposites of each other. I was going to say, I thought we did.
It was on the notes.
Okay. Well, 12?
We didn't even do 12.
Because Brian said to do 12, you know? 13? 13? 13? All right, let's do 13. All right, 13. We got alpha is 43.1. We have A equals 184.2. We got B equals 242.8. Again, this is another one where I'm going to use a quadratic. I can tell you use quadratic because the two pieces they gave me are two that are across from each other. I'm going to go ahead and look at the first formula. Do note, in general, you want to use the formula that you are given an angle for. That is the golden rule. Use the formula you are given an angle for. So I'm going to use the alpha version of this formula. I'm going to plug into the alpha version of this formula to find the missing side, which means I use the first formula. Let's set it up. So to set up, I'm going to use a squared equals b squared plus c squared minus 2bc cosine of alpha. I'm going to plug into that formula the three pieces we were given, and anything I don't have, I'm going to leave as a variable. So I have alpha as 43.1, I have A as 184.2, I have B as 242.8. So let's plug them all in. 184.2 for my A, 242.8 for my B. My C squared is not known because I don't know what C is. Minus 2 times my B value, which is 242.8, times my C value, which is unknown, times cosine of my angle, which is 43.1. So you'll notice that I have C's as the pieces that are unknowns. I'm going to go ahead and set this up as a quadratic. To do so, I got to simplify everything else. When I simplify everything else, it's a lot of calculator work. So, grabbing the calculator out. Left-hand side, I'm going to take my function. I'm going to square 184.2 and get left-hand side 33,929.64. Okay. 242.8 squared is 58951.84 plus c squared is still c squared. Now, all of these pieces over here, I'm going to go ahead and multiply all together. So 248.2, and cosine of 41.3. I'm going to multiply those three things together, and then there'll be a c attached to it because it's all that times c. So I take minus 2 times 242.8 times cosine of 43.1, and I end up with minus 354.57c. You notice that this equation is a quadratic because it has a c squared, a c, and a bunch of constants. So I'm going to solve this like a quadratic by first moving my number over, making it equal to 0, and then plugging everything into the quadratic equation. Here we go. Step 1, I'm going to move this 33929.64 over to this side. This is a requirement of using a quadratic equation is I have to have all the numbers on one side with all the variables and then making it equal to 0. So this ends up being 0 is equal to, okay, we have c squared minus 354.57c. And I subtract those two numbers. When I subtract those two, I get plus 25,000 and 22.2. Wow, there are three different 2's in that number. 58 951.84 minus 33929.64. Yep. 2, 2, 5, 0, 2, 2.2. Added a lot of twos. All right, quadratic equation now. Quadratic equation allows me to find C, and then I can continue on the problem. All right, setting up the quadratic equation. The quadratic equation is, over here in the corner, negative b plus or minus square root b squared minus 4ac all over 2a. Do not confuse the c in the problem with the c over here. They're different letters. One c of the equation, one c of the problem. So I want to plug everything in. This would give me my value of c is equal to negative b, so 354.57 plus or minus the square root of b squared, so 354.57 squared minus 4 times a, which is 1, times c, which is 25022.2.
Doug,
Yes.
wouldn't that
All over.
B be negative?
No, because anything squared should be composite, right?
But on the, oh, I guess it doesn't matter because the outside goes to negative always been.
Yep. And so the negative and negative would make it positive.
Oh, never mind.
Alright, now again, this will give me two answers, but one of those should end up disappearing because we should only ever have one with the law of cosine. It'll disappear because we'll end up with a negative number. So I'm going to take everything under the radical and simplify that down first, giving me c is equal to. And don't forget, you can always use mode 5-3 to find these solutions as well. If you have the Casio calculators, those work really well for doing the quadratic equation. I would get 354.57 plus or minus. We take this entire radical and plug it all in. The square root of 354.57 squared minus 4 times 1 times 2, 5, 0, 2, 2.2. And I end up with 160.097. So 160.1. All over 2.
That's it.
So in this case, I do end up getting a second solution when I subtract these two numbers and divide by 2. So I'll need to see which one of these is the right one by investigating what information they gave me in the problem. Here we go. All right. So my two solutions should be 354.57 plus 160.1 over 2. So 354.57 plus 160.1 divided by 2. My first solution I get is 257.335 or 3, 4. Or 354.57 minus 160.1 divided by 2, or 97.235. Okay. So I ended up with two solutions. Let's see if there's any context in the problem that can tell me whether one of these solutions is right or wrong. So I want to look and see what the information I have in the problem is. If I look at the numbers that I started the problem with, I have my alpha is 43.1. My A is 184.2. What I want to point out here is this is an idea in geometry that comes up a couple times. My A is smaller than my B value. You know what? I'll pause here. Let's explain which one of these two answers is correct when we get back from lunch. Pause right here.
Oh, were you still making?
Go. All right. We have two solutions. What I want to point out here is that with some information contained from above, we can actually determine if either the solution is correct or incorrect. Here we go.
Tyler, you're such an overachiever. Okay, you do your work and like from instead.
So here we go. We have three sides to a triangle, right? There's a thing about geometry that is often forgotten when you start getting into trig because we care a little less about some of the old theorems and stuff. One of the ideas is that the angles and the sides are always related to each other. Meaning the shortest angle is across from the shortest side. Longest angle is across from the longest side. Middle angle is across from the middle length side. If you look up here, we have 43.1 degrees as my alpha, and that should be across from A. Now, 43.1 is not like a huge angle. It's kind of in the middle. But look at the three numbers we now have as possible sides. We have 184.2, we have 242.8, and we had 300 and something down here as another possible answer. That would mean that 41.3 or 43.1 would have to be the smallest angle we could have. That's pretty unlikely, just because of the numbers that you're dealing with in this situation. It's pretty unlikely that 43.1 is going to be the smallest angle in this list. So of these two possible answers, it is far more likely to be this 257. Because in this case, like this number makes sense with the context of the problem itself and how it fits together. You can look at the triangles and the sides and angles and make judgment calls. This is what few things in geometry can be helpful in parts of trig. Because otherwise, we have two answers and we have to work with both to find our solutions. So do note that for these kind of problems, it is entirely plausible to work through and find solutions with these techniques. But you may want to use some outside information to help eliminate possible options. Like how we've used the triangle angle sum theorem. Because otherwise we have to use the theorem a third time. Like how we've used that fact of positive angles versus negative angles in a triangle. Right? We're supposed to have positive answers, so if we get a negative, we know it doesn't work. Those kinds of things, all pulled from geometry, can make our trig work easier. Okay? So, now that I've got my three sides, 257.34, and these three, I can now find the missing angles using the law of cosine's second formula, which I will now do. Remember, my goal is to find all three pieces that are missing. I have found the missing piece C. Now I find the two.
Can you use law of sine to find like the opposite of B?
Yes, you could. You could use the law of sine instead. That would also work fairly well. It is possible when using the law of sine, though, to get two possible answers, like we had with some of the examples from last week. So you have to make a judgment call. Law of cosine is a little more complicated, but it guarantees one solution most of the time. Whereas law of sine tends to have a lot more times where it's going to have more than one solution. And so you have to make a judgment call about which one is appropriate. 9 times out of 10, if you want to ask my personal opinion, I use the law of cosine. I think it's better. Even if it means I got to use a quadratic equation, I still think it's better. So I got my three sides and one angle missing. Let's find the other two real quick. So.
Yeah.
Oh, there we go. So we don't need to find the other triangles. We're done. And it says, if possible, meaning it's possible that you end up with more than one solution. This could be a situation where you look at it and say, hey, I got two solutions. I got these two solutions, and you'd be valid to put both answers down. Because it said, if possible, find a single side. Since I got two answers, that may mean that a side, without more information, without more context, without more theorems from geometry, I can't find out which one's the right one. So in this case, these are my two answers, and the only two answers I get for number 13. Thank you for catching that, because otherwise I was going to keep going, because I can't. Okay. Any other problems in the more guys more?
I was just out of it.
It's Thursday. We got 5 days, including today, left. Let's do it.
That's just makes me out.
This is my spirit animal. Number 15. We have beta is equal to 50 degrees. We have A is equal to 105. And B is equal to 45. If it says it's not possible, I have a guess. Probably when we use the quadratic equation, both end up being negative. So that's my go-to guess, is that when we use the quadratic equation, we actually will somehow end up with both being negative. I'm not sure how that's going to happen, but that's my guess. Let's try it out and see what happens. Okay, so I'm going to try number 15. Again, I'm going to use the beta version of the equation. Notice the angle dictates which version of the equation you should use. Okay, so since I have beta given to me, I'm going to switch this equation into the beta version, which is a modified version of this one. And so it would look like b squared equals a squared plus c squared minus 2ac cosine of beta. This is the beta version of this top equation. Again, the angle dictates which version to use. So I will now plug in the information that I have, a, b, and c, into this equation along with beta and see what happens. So b in this case is 45. My a is 105. Once again, c is unknown, so I just leave it as c. Minus 2 times 105. So what?
Why is it always C?
I don't know. Why does algebra always use x and y? I don't know.
You probably won't. I've never understood that either.
You know, my high school teacher used to make a terrible joke. She'd always say things like, it's because mathematicians have bad relationships. So you always want to find out what's going on with your ex and why it happened. Huh. She'd been divorced 3 times by that point, so I can't think of it. Alright. That was a bad joke. Okay. Let's go ahead and do this pieces. Alright, 45 squared.
Got that experience, Douglas.
I do not, so I'm quite happy. 2025 equals 105 squared, which is 11025 plus c squared minus 2 times 105 times cosine of 50, which is 134.99 c. Questions so far? Just plugging everything into a calculator. Now I'm going to move the 2025 over and see what happens. I move it over, I end up with 0 is equal to c squared minus 134.99 c plus, and then 11,025 minus 2,025. I end up with 9,000. Okay.
That don't look that bad.
It really doesn't. So let's see what's going on. I'm now going to use quadratic equation, see what happens.
Look worse last time.
It did. Alright, here we go. So I plug in the quadratic equation. Again, that quadratic equation is negative b plus or minus square root b squared minus 4ac all over 2a. And so I plug it in, and here's my formula. So my c value is equal to negative b 134.99 plus or minus. Again, it's positive because I have a negative in the formula and a negative in the problem. Double negative makes it positive. Big square roots. 134.99 squared minus 4 times my a value, which is 1, times my c value, which is 9,000. It's over 9,000. All right. Divided by 2 times a, or 2 times 1. And I think I know what's about to happen. I think inside the radical, we end up with an imaginary number. All right, so I take this one. I get c is equal to 134.99 plus or minus. When I do the radical, I will get an imaginary number. Some calculators will actually tell you the imaginary number. Some will just say error. And so like mine up here, when I plug in the radical, it will tell me error. When I plug it into like some Casios, it will actually tell me the I answer. And then I know it's wrong because it has an I in it now. So let me go ahead and plug it in. 134.99 squared minus 4 times 1 times 9,000. I end up with the square root of negative 17777.7. And because I have a negative inside the radical, this tells me it is imaginary. And because it is imaginary, I cannot make this triangle. So that is why 15 has no solution. It is because we end up with a negative inside that radical, and negatives inside the radical cannot possibly create real answers. So this cannot possibly make a real triangle.
Can I use the Yeah, that one, if you go to the very end of the calculator, the very end with the arrows, it shows the y at the end. Oh.
She's right. Good call. Yeah, so make sure you double check. Those Casios are great. I love them. Like, that's why I tell people to buy them. But sometimes they have that little thing where it's just like, oh, if I just went over a little farther, I'd realize there was a problem. I'm a huge fan, but sometimes it can still be not as good as. Okay.
It's good in some ways.
All right, 21. 21 says. We have A is equal to 35 degrees. It says B is equal to 8. C is equal to 11. All right. All right, on 21 it says solve the triangle. Now we talked yesterday, the phrase solve the triangle simply means find all missing pieces of information. So find any missing angles and find any missing sides. So real quick, I'm actually going to make a little list on the right hand side. Let me remind myself what 3 pieces I need to find. I need to figure out what A equals, that's the missing side. I need to find out what capital B is, because if you notice the notation, capital A stands for the angle, therefore little a would stand for the side. So capital B would stand for the angle, and I also want capital C in this problem. So let's find little a, and then we'll find big B, then we'll find big C. Order is not terribly important. I prefer, when possible, to find the missing side first. That is because I like the top formula. The top formula is the one that's on your cheat sheet. So I typically use that one first when I can. So here we go. I want to work to find out what little a is. And luckily, that's the formula we have on the board. Little a, or a squared, is equal to b squared plus c squared minus 2bc cosine of, in this case, capital A. So I plug my stuff in. I will end up with little a squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 35. Okay, 8 squared, that's 64. I'll actually show my work this time. 11 squared is 121. 2 times 8 times 11, that is minus 176 times cosine of 35. Once I get to something like this, I'll go ahead and grab a calculator and plug everything in. So 64 plus 121 minus 176 times cosine of 35. I end up with a squared is equal to 40.829 blah, blah, blah. I say blah, blah, blah because I'm not going to round yet. I don't want to round until the end. Last step, I want to get a by itself. I don't have a by itself, so I use some algebra to get a by itself. Square root both sides. A is equal to the square root of that number. So square root of 40.82 blah, 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 blah. And the square root of that number is 6.389 or 6.4 when we round it. There's our missing side A. 1 down, 2 to go.
I have a question.
Yeah.
So, on the answers in the back of the book, I have 45.9 and about 46. Is that okay?
Yes, it's 0.1 off. Yep. Okay, you're talking about 21?
Yeah.
Oh, cool. All right, so now I'm going to find big B and big C. To do that, I'm going to need to use the second version's equation and one of the modified ones. So big B would just be cosine of beta. It's the same basic formula, just B instead of beta. And big C would be cosine of gamma, same equation, just with gamma instead. So I'm going to use those two. And once I have those two, I'm going to plug everything in and get my solution. Here we go. So in this case, A was 6.4. So B, come over here, I use the cosine formula. Cosine of B is going to be equal to B squared plus C squared minus A squared all over, oh no, sorry. I'm reading the alpha formula. The B formula is A squared plus C squared minus B squared all over 2ac. So I plug everything in. Cosine of b is equal to a squared. So that was 6.4 squared. C squared, that's 11 squared, minus b squared, so that's 8 squared, all over 2 times 6.4 times 11. Then right hand side, I'm not even going to bother simplifying any of that. I'm just going to plug it all in. So I take 6.4 squared plus 11 squared minus 8 squared. Help if I press the right button. There we go. And then divide that by 2 times 6.4 times 11. And I end up with the following number. Cosine of b is equal to 0.6957 blah, blah, blah. Again, I'm not rounding until the end. I will then use the inverse and plug that number in. And that tells me that the answer we get for b is 45.913 to 45.9. If you rounded this top number to like 0.7, like 2 decimal places or 1 decimal place, it will give you an answer that's closer to 46, which is close enough to still count. Again, the fewer times you round, the more accurate your answer is going to be. I use the answer button on my calculator a lot. If you don't know what that is, it is great for these kinds of problems that you're not constantly typing in big, long decimals your calculator gives you. You can just use the answer button and it will plug in whatever the last thing you had was. Super convenient. And then lastly, to find the last angle, triangle angle sum. I have 2 of the angles. I know one is 35 and the other one is 45.9. I can find the missing angle by adding them together, subtracting from 180, which means the missing angle is big angle C, 180 minus 45.9 minus 35. I get 109.1. There are my 3 answers. A, 6.4, big B, 45.9, big C, 109.1 FM. Yes, thank you for pointing that out. I happened to press the number wrong. It should have been 99.1, not 109.1. Always double check with the back. Always double check you typed everything in right, because if not, there's a good chance you make a mistake, and you may not know it until somebody says, hey, dummy, you made a mistake. Okay. Boom, 37. 37 has the following picture, and it says in the instructions to find the length of side x, round to the nearest tenth. That's good. All right. You have the following picture. It's a pretty picture. We have 1, 2, 3 as our degree. We got x right there. We got 1/5, ooh, and 1/3, double ooh. All right. Luckily, this is a straight law cosine problem because if I look at how my information is presented, I have 2 sides, and the angle between. That's the easiest setup for using the first part of the law of cosine. So I'm going to set it up. I'm going to try to solve. The biggest thing here is if you don't have a calculator, there's a lot of little math to do. So I'm going to try to do it all without one. Let's see what happens. Okay, this is going to be my quote-unquote A because this is going to be my alpha. It doesn't really matter if you call it A or alpha or something else. None of that stuff is a big deal. What really matters is that you have all the right pieces put together. So I'm going to put it up. Here we go. So x squared, that's my A, is equal to my B squared, so 1/5 squared plus 1/3 squared minus 2 times 1/5 times 1/3 times cosine of 1, 2, 3. So there's my big formula. You might ask questions like which one should be B, which one should be C. It's not going to actually change the result because in the end, they still have the same basic structure. So I'll plug it in, and now let's see how well I can do without a calculator here. X squared is equal to 1/5 squared is 1/25. 1/3 squared is 1/9. 2 times 1/5 times 1/3 would be 2/15 times cosine of 1, 2, 3. I cannot do cosine of 1, 2, 3 on my own because it's not on the unit circle. I can get close because it is close to 120, but even then, still can't do it. So I'm going to go ahead and take this, plug it in the calculator, and see what happens. So 1/25 plus 1 over 9 minus 2 over 15 times cosine of 1, 2, 3. I end up with x squared equals 0.2237 blah, blah. I don't want x squared. The problem doesn't have x squared in it. It has x in it. So I make sure to make my next step, which is I want to take a square root of both sides to get x by itself. This means that x is equal to, I square root both sides. Again, I use the answer key a lot because I don't want to type that big long nasty decimal in or risk typing it in wrong, as you saw in the last problem. And so I use the answer key and it tells me that x is 0.473. And the problem said round to 1 decimal place. So we're checking instructions. And the nearest tenth. That means my answer would be actually 0.5, which is a pretty big round for this problem, but it is the answer. That is number 37. Just making sure to know your formula well enough to plug it in and find your solution. It's a good problem. Right?
Is 21 a log sine problem?
So on a lot of these, you could do a log sine. When you have your final, there'll be a question that says use the law of sine. There'll be a question that says use the law of cosine, and there'll be another question that just says find it. So you could use either one depending on what your preference is. I would strongly recommend in this assignment use the law of cosine for all of them. Just get some extra practice. That one does, I believe, end up becoming a very nice law of cosine problem. In fact, it's really hard to do with the law of sine because how the pieces are arranged in the problem. So if you look at 21. Yeah, because the pieces they give you don't match up as opposites. They tell you capital A, they tell you little b, they tell you little c, which in a triangle, those three never match up. So big A would be like in this corner, big B would be like over here, big C would be right there, and then opposite of each of those would go these sides, little a, little b, and little c. And the problem is you never have any pairs that work. Like there's never a big A and a little a that you both know, therefore you can plug it in. There's never a big B and a little b. There's always one missing, so the law of sine is just bad. It does not work very well.
Law of sine, you have to at least have a pair.
Have to have at least one pair in order to get it to work. So this one really wouldn't work very well.
Yeah.
Ones like 7, 9, 11, 13, 15, those are law of sine problems that you could do with law of sine because of the information they gave. But they're also law of sine ones where you end up with more than one solution because of how it's arranged. Because you end up with a side-side angle as your pieces. And so even the law of sine on those ones is not ideal.
Yeah, I was looking at 21 on 10.1.
Yeah, 21 on 10.1 would be a law of sine problem. Okay, other ones. All right, 17. Find angle C. I've got my three pieces. A is 14, B is 13, C is 20. That's good because law of cosine, if I want to find an angle, I need to know all three sides. Well, I do. So all I got to do is use the modified version of the second formula to figure out how to do it. In this case, I'm going to use the third version. We're using gamma because gamma and C are essentially the same. It's just a different notation. So let's use that third version and see what happens. We get cosine of C is equal to A squared, so 14 squared, plus b squared, so that's 13 squared, minus c squared, so minus 20 squared, all over 2 times a, which is 14, times b, which is 13. And that top piece, all of those numbers can be found by standard math. Let's see. Cosine of c is equal to, okay, on top, 12 squared plus 13 squared minus 20 squared. The top is negative 87. The bottom, 2 times 14 times 13 is 364. So we end up with this fraction, or the decimal version of the same note, which is fine. Again, I want to get capital C by itself, so I take the time to use an inverse. So I will inverse both sides. The left-hand side becomes just C. The right-hand side is cosine inverse of this fraction we just found, negative 87 over 364. And then that's a calculator. So I take my calculator, I type in cosine inverse of negative 87 over 364, and I get the following. C is equal to 103.82 or 103.8 degrees. The problem only asks me to find C, so I am done.
What, diamond? Think what I'm doing is good.
A little bit.
Why is that? And think what I'm doing is good.
It's this.
How is it?
You left your open. On down.
Down is pretty hard. Really hefty, right?